hope that you enjoyed the first day of Scale by the Bay in person back after years. I'm here with you. I'm Oli, if you don't know. One of co-organizers. Alexei is the founder, and I'm a co-organizer. Also, I do devreal and community for Byte. And this panel is going to be about the streaming technology, and we're going to experts in the area, their opinions on the technology, where it's going, what to expect, and more. So, honorable ladies and gentlemen, please come to the stage. Okay, so I want to warm up a little bit with the short introductions. So let's just be boring and go from left to right.
Is this on? Yeah. So I know Oli well because I am the founder of ByteWax, and so I work with Oli on a regular basis. Yeah, I live a little south and west of the Bay Area in Santa Cruz. I talked about ByteWax in my talk, but it's a stateful stream processor, so I'm here to talk about streaming data because it's something I think about on a regular basis. And I don't know what else I was supposed to say, but that's me.
I love it. I'm Tim Berglund. I work for a company called StarTree. We make a fully managed cloud service based on Apache Pinot, which is a database that doesn't make a lot of sense outside of a world of streaming. And what else about me? I live in Mountain View with my wife and my stepdaughter. I have 3 kids, 3 grandchildren. I have hobbies. We can talk about that later.
Hello. Hey, everyone. My name is Jerry. I currently work at a company called Databricks. Hope many people have heard of that. I currently work on structured streaming or Spark streaming at Databricks, and that is what my team is responsible for, is developing, maintaining, and supporting structured streaming and Spark streaming, both to internal customers, but also to external customers as well. And I've been kind of working on streaming kind of my whole entire career. If people have been around in this space, worked in a lot of open source, Apache Storm back in the day, Apache Heron, and then moved over to PubSub, some on Apache Pulsar, and now on Spark. I live in Santa Clara, been in the Bay Area for a while, love to play tennis.
So my name is Mary Grygleski. I'm a developer advocate at DataStax. So if you are familiar with Cassandra, then that's the company that we are the commercial arm, I guess, of Cassandra. But actually, I joined DataStax last year. First, I was with the streaming team. So I worked on Apache Pulsar there. And then about 4 months ago, company has kind of this mandate, everybody is going to work on Gen AI. So anyway, so that's what I'm working on right now. And in fact, my talk here I just did today was about boosting LLMs with event streaming and RAG pattern. So that's my talk there. And I'm also active with the Java community. I'm also a Java champion and also president of the Chicago Java Users Group. So very honored to be here. Thank you.
Hi, I'm not Holden Corral, who could not make it here today. I'm Dean Wampler. I also live in Chicago and was involved in streaming a lot in my days at Lightbend, which is the Scala company many of you know. Currently, I'm at IBM Research working on their Watson X generative AI platform and their AI strategy for open source.
So combined, these people have years, decades of expertise in streaming. And I want to kick off the discussion with the question, why is streaming happening? Is it a fad or a response to real and durable trend? Like, if the latter, what are the trends? And Zander, you have to start this.
We're just gonna go around and around. So the reason I got into stream processing was because of machine learning. So the reason we built ByteWax was to help solve a problem in real-time machine learning, and that problem was that it was very difficult to do the same transformations to the data that you did to train the model, which happened in an offline fashion, to then do those online if you wanted to do your inference in an online fashion. And so if I was to speak about some trends that would lead to us suggesting that maybe it is a durable thing, I would say that my experience would suggest that as there's an increase in machine learning, then there will be an increase in stream processing to solve some of that problem. So I'll say that's where I come from. So I'll leave it on to the next. I don't know how we're gonna continue to do the little.
No, we don't have to. Actually, if someone wants to step in, Jerry.
Sure. So, give a little context about my journey in streaming, right? I started my journey in working on stream processing in grad school. This was many years ago, right? My advisor told me, Jerry, go do this thing that I didn't know anything about, but he said it was the next hot thing, right? And that was kind of the story for a long time is, oh, streaming is the next hot thing. But I think, now we have arrived at streaming is the thing, right? Like people are starting to really look into it, and we see that at Databricks, how much like usage we've had on structured streaming. So I think one of the reasons why is one is I think education, right? People now understand what streaming is and the value it brings, that there is an opportunity cost for waiting too long, right? People for the longest time in big data, right? They're like doing batch processing once a day, once whatever, like longer duration of time. That was good, right? That was moving from a situation where that was not even possible. But now, as technologies have developed, as people understand technology better, they understand, wow, if we can process this data quicker, we can make decisions quicker, and we can take advantage of situations quicker and generate more value. So I think nowadays people realize that a lot better than before. So that's why there's definitely a rise in the popularity of streaming.
I like the question because there's no question that streaming is happening, the way you asked the question, Oli. But sometimes these things, we experience these things in software and they don't endure, right? They really are just a thing that everybody rushes to.
Blockchain.
I don't want to, it seems like this is the wrong crowd for Scala jokes, but you could do that. But, we rush to these things because we are preoccupied with trying to discover what's next and get some advantage in how to build things. And, could it be that is streaming? Now, I don't think so. That would be moderately hypocritical of me if I thought that. But I like the question because just the fact that we're all interested and there's conferences and you go to the expo floor and everybody has to say streaming on their thing, that doesn't mean anything. So what I look for are things outside of us. Why is it that we don't allow 4 to 6 weeks for delivery? So that's the thing that TV commercials used to say. That's not, you don't submit a request and get something back a long time ago. What's changing in the world that would make right now so important? Because there isn't a question that anybody here who builds things, getting an answer right now is what you have to do. It can't be tomorrow anymore. And why is that? It always feels like a cheesy answer, but honestly, I think smartphones are a driver of that they're not a new thing anymore. You've had one in your pocket for a good 10, 15 years. And that transition that I don't know that we really adequately noticed from I go to a computer to use the internet to it's just there and it wiggles. When the state of the world happens, it gets my attention, and more of my commercial and social life is mediated through that device, and it's always on, it's always there. Well, those of us who are building the systems that drive that activity, now is when things need to happen. We don't get to wait. So I think streaming is real, and I think streaming is a response to that.
Can I add on to that? But I do want to give the other panelists.
Yeah.
So I think completely agree with what Tim said here. Like obviously the rise of IoT, right? Like phones and whatnot. But I think to add on to that, I think especially working in open source and working at some companies that have adopted open source like Yahoo, and whatnot back in the day, a big driver of streaming technology and also Twitter, right, is originally, like in the early 2010s, was actually ads, right? A lot of these internet companies, why are they developing or leveraging streaming technologies was to drive real-time ad campaigns and real-time analytics on those ads. So it was very important for them to develop these technologies. And that gave like a boom, essentially, especially in developing streaming technologies, especially streaming technologies in open source. So that's all I wanted to add as well.
I'll add one more advantage of streaming, and that is that you basically amortize the processing load over smaller chunks. Like a typical Hadoop scenario, especially on premise, was you have this cluster sitting around all day, and then suddenly you spin up a big job, every few hours to process data. You don't need to do that if you're processing it as it arrives.
And I think for me, I would think more from consumer or user's perspective too. There are also cases in which in today's world, right, there's fraud detection system, for example. You do need techniques that comes from event streaming to help it. And you can't wait, those things, something suspicious, you want to take action right away. So that kind of demands and, it becomes like a mandatory thing. We need to actually have applications that have to be able to respond quickly, and there's no time loss. And I think that's, it's no longer a fad. We do need streaming technologies, how I'm looking at it, so.
Okay, then I want to zoom out a little bit on this because many of you mentioned insights that we can get from the streaming data, but we are all technologists. And one of the ways to look at the streaming data is also the connectivity between different pieces of your design architecture. So my question is more like, okay, so we got the insight part, but is it the better way to connect your microservices or whatever pieces you have?
Yeah, I think that's a good question, and actually that's the hard part in a lot of cases. It's just too difficult to hook things up and keep them reliable. So I think there's plenty of room for innovation in the people who are really working hard on this, like Pinot and Kafka and all of that. So I do hope that it becomes so easy that people stop questioning whether they should do it. It just works. That's really what we need to get to.
Fair point. Like, we're early days. There's a pipe, and you can put things in it, and you'll get things out of it. It all feels very bespoke. It's like you're gonna have to, cut the threads on the pipe and all those things. It's the pieces are not well developed, but it seems like my answer to your question would be yes, because, and again, it takes time to validate these things, but we've been microservicing for 13 years, and it seemed like it was a terrible, bloody exercise at first that was just failure. And then there was kind of a middle period of like, all right, we can do this synchronously and, kind of build a bunch of scaffolding around synchronous services and the new asynchronous event-driven thing. It seems like it's working, right? Like we need another 5 years to tell, but it seems like it's actually, and that by the way, Dean, that's the other driver that I think of. I think of mobile, and I think of the way we choose to build applications now, which is services, and events are a good way to connect them. I think it's working. Like, let's find out, but seems good.
So I think there's a couple of hard problems in this area. Sure, one is always building connectors, right? But that's always been the case for a while, is you develop some sort of new framework. Build connectors, it could be, microservices or whatnot. But I think one of the things I've seen more recently is when you have basically, chains of microservices, right, that work for whatever purpose, right? Microservice A feeds to microservice B, feeds to microservice, whatever, right? What if there's a failure in between? How do you recover, from that situation? How do you recover consistently from that situation? That's one of the harder problems, is when you have chains of microservices. It almost resembles stream processing to some degree, right? How do you effectively and consistently recover, from failures from, between, and still deliver a correct result at the end, right? Or deliver correct results to the end user. And number two is, a lot of it is also observability. Is though there's a number of frameworks out there, I think, to help observability in your microservices, but how widely is that adopted is how do you like actually monitor the performance and the health of all your microservices. That's surprising to me in a lot of even large organizations. That's almost still very rudimentary to some extent.
It feels like we are just barely at the point in the development of this stuff where it might be a little more good than harm. Because like you said, those things are just not obvious. I mean, there are answers. I was listening to a podcast episode about temporal this morning, which is a thing that answers the first question. And there's all kinds of observability things, but they're not, it's not obvious, and we don't have the one baked kind of way to do it. And I think of this analogy of the development of medicine. You know, there was some time, I think, because I'm a historian and people come to me for my opinion. No, they don't. But I think somewhere in the middle of the 19th century or towards the end of the 19th century, like the practice of medicine came to be probably more good than harm. Like there was some inflection point, you were like, it was better than even money to go see a doctor. Before that, you know, and we're maybe at that same point with some of these things where, you know, sagas, there's just no real consensus way to do that. Are there ways to get it done? Yes, but gee, that's a thing. We just don't know yet. We haven't been doing it for very long, and maybe we're on the cusp of that. This is actually slightly more good than not. And that's, which sounds terribly pessimistic. I mean, I'm completely optimistic. This is, as I like to say, there are people who are right now somewhere learning how to eat food because they're little babies who will be using the paradigms that we're talking about professionally as software developers in 20, 25 years. We're onto something real here, but it's early.
But there is certainly delay between medicine start working and people believe in it.
Yes.
Yeah, so let's unpack a little bit on the challenges that we meet with the streaming. And first one, already mentioned, is that the streaming seems to be disrupting the application stack. So if before it was clear, use the web framework, use database, everything is clear. Now it's like a suite of different microservices connected by Kafka, and then you use some sort of streaming. Which streaming? We don't have an answer. We have a gazillion of different frameworks. Now we have to choose, and your company does this. Why? Nobody knows. Everyone forgot. Or it's just simply because you have people who are expert in some frameworks. You just keep using it and going, but at the same time, so many things are happening. And I think streaming is one of the turbulent things where like a lot of things happening at the same time. So my question would be, do you see that it'll be stabilized somehow in a few years, say 5 or fewer?
So, okay.
Mary, one,
Go.
No, I meant to say that I feel, right, this whole field is like we're going around in circle. I mean, not just in streaming. If you look into all of the things in computing, it seems like, you know, we go from single thread to multi-thread, or it's back to, oh, it's actually not too good, and it goes back and forth. I feel that maybe to everything, there's like a balance point, and maybe we're trying to reach that. And what it is, maybe we're in the journey of discovering it right now. So the same thing maybe for streaming too. We're talking more about it. It should be like this and should be like that. Use Kafka, use Pulsar, use this and that. And then now there are people actually using, there's another net, right? They are very simple net for also doing messaging too. So that's kind of completely kind of like a bare bone kind of like thing. So I feel like, well, are we going back to, you know, kind of something simpler to use? I don't know. This is actually a very interesting thing, and I do like how you raise the question up and applies to everything too. So yeah.
Tim's the historian, so he can probably tell us that human nature to repeat itself. I think it's really interesting to think about what you were just talking about with respect to microservices as well, and the way we grab on fads and trends as an industry. Specifically, if we're to think about this conference and large language models and generative AI, and I talk about this effect of like the boardroom trickle down. And so like someone in the boardroom is like, we got to do something about generative AI, and then it slowly trickles down to whoever has to implement it. And so maybe the reason we're at microservices, like, oh, hey, some FANG company said that like this, Google or something like that, I don't know, said that this is a really good pattern, we should all follow it. And then the boardroom trickle down effect happens, and then we all have microservices, irrespective of if we want it or not. And at some point that can happen with streaming too, and I think like other people have sort of alluded to this, but what I'm trying to say is like, I don't necessarily think that we make the best decisions for ourselves all the time. And sometimes there are things that we can't totally influence, and so it's really hard to like strongman or steelman or whatever, be strong against the forces that, you know, essentially feed your family or whatever it might be. But I don't know, I just wanted to add that in when we talk about like, are we making the right decisions? Is this a fad and all that? And there's sometimes it's so complex, and there's so many things that we don't control on these sort of things.
So I'd like to offer maybe a slightly contrarian opinion. Contrarian is a strong word, but we have to remember that microservices are a solution to a problem. They're usually about scale out or, you know, team boundaries and all this kind of stuff. But it's kind of bad that we actually can't use monoliths. Let's be honest. It would make things so much simpler if we could just do function calls. So I like to think about that every now and then to make sure I don't like just, you know, drink the Kool-Aid too much and really understand why I'm using stuff. And one of the revelations for me, so I worked for Anyscale for a while, the company behind Ray. And what a lot of people don't realize is when you actually use Ray, behind the scenes, it's scaling out your work as tasks over a cluster. So you can kind of go back to just having like one entry point per microservice or service instead of like 5 because you have to scale out, and just let Ray do a lot of it. So I'm hoping that things like that will actually kind of force us to rethink, well, maybe if I can scale out completely my one microservice over a cluster, I don't have to do streaming between instances of that microservice for whatever reason, and that makes things simpler. And the simplicity is like the most important thing we can do in this business to, you know, keep our sanity. So I'm not trying to trash anything, of course, that we do, because they're all great solutions, but it's really good sometimes to step back and think, how can I make this simple? And what tools do I have at my disposal for that?
I don't think it's that contrarian, actually. We don't all need microservices.
I hope there's nobody up here who thinks you should never build a monolith. I mean, I think you should default to that, and we just get it beaten out of us.
I said it was a strong word.
Yeah.
Okay, so what Dean said about scaling actually bring us to another challenge. So streaming in real time can be can eat a lot of resources. It's really not a cheap thing. So you have to think twice if you need it at all. In your opinion, how companies are solving this problem right now?
Well, I don't necessarily think that, to be honest. I think it's always going to be a trade-off for companies, what they're going to trade off, cost versus latency, right, or throughput versus latency. It's always a trade-off between that spectrum, right? Is how many dedicated resources you're willing to commit to run this specific thing, thus how low of a latency you can get it, right? For example, in systems like Spark, right? It is easier to trade off cost and latency, right? Because imagine you have a streaming query, you have many stages. You can say, I only want to run one stage at a time, and my cluster is always provisioned to run one stage at a time, right? Versus I will run all of the stages at one time and have a larger cluster dedicated for running it, right? If you run all the stages at once, you may be able to get lower latency, but you have to commit more resources. Versus if you have a smaller cluster and I can have only lower concurrency, I have to run fewer things at a time, you would incur larger latency. So it's at the end of the day, like coming back to the requirements of what you want for streaming, right? Streaming does not necessarily mean you have to process something in a millisecond, right? It could be you just want to, your SLA is 10 minutes, an hour. It's not really defined here. It's really defined by the use case of how low latency or how high latency your requirement is. And based off of that, what are the cost implications? So I think there are definitely ways for users to mitigate costs. And a lot of users, especially using structured streaming at Databricks, latency is actually not, for a majority of them, latency is not actually a very high concern. A lot of it is cost, especially on the ingestion path, is how little money can I spend doing this? Oh, come on, can't be the only one.
Could there be selection bias in that? In not seeing customers who are concerned about latency?
Sure.
Yeah.
They're all using Flink instead, or is that what you meant?
They might, if that's the thing they're optimizing for, they might. Because I think you made a strong point about we only have trade-offs to make. I mean, we're engineers, that's what we do. And pretty much anybody only gets to make trade-offs. You don't really get to solve most problems. You just push the piles around. And that you made that point strongly, but latency not mattering to me sort of brings it out of the world of streaming. And we don't have a robust definition of what streaming means, but informally, I always try to define it as I have a thing and I'm going to do something with it right now. I'm not going to put it somewhere and come back to it later to do something with. Now, if it's Kafka, I'm putting it somewhere and I can still go back and do something with it later. But, my pipeline is I have an event, I do something, rather than, I put it in a bucket somewhere and I go back and run a process on it later. That would be batch. So there is no implied SLA in just saying streaming, but I feel like definitionally there is the implication that I mean to get to this right away.
Oh yeah, I definitely agree that if it's streaming, latency is definitely going to be a dimension. It's just a matter of how high or low is that, right? Sure, you can say selection bias, Flink, maybe they do have the best latency. But that's also relative, right? That's relative in the world of maybe, soft real time, or in the realm of in the milliseconds. I've also worked in finance, where we're literally running this stuff trading on FPGAs, and we're dealing with
nobody's using any of this stuff because we're all dinosaurs there. Yeah.
Sure, right? That's the thing. Everything is kind of relative, right? But I think there are more and more use cases that would require latencies in the milliseconds, and we see that at Databricks, and we are actively improving latency in structured streaming to basically handle those use cases. Nice. But the thing is, even not at Databricks, at my previous life, at working at a startup, working at Yahoo, the reality is many people, especially coming from Hadoop, and they're if you can give us minute latencies, that is already good enough. That is we are happy with that. So that's why it's hard sometimes to justify engineering work, right? It's we have to build this thing to deliver that latency, but then people ask, well, where are the use cases?
And
right.
So I think that's a super interesting question, which sometimes gets asked of me, because I'm the guy who's 15 milliseconds is too long, That's an exaggeration. But when do we need real time? Introducing that term into the conversation. And it's probably not for business analysts looking at dashboards in most cases. It just doesn't, a minute is great. I mean, yesterday is too long. That's from the 90s, but man, 10 minutes ago is pretty much okay for most executives, business analysts making decisions. You don't need those things to be faster. So I took a question after my talk, or I think it was after my talk. Yeah, if you can make an analytics database 1,000 times faster, it is not valuable for that dashboard to refresh 10 times a second or 50 times a second. And you also don't need to make 1,000 times more of them. You don't have this pent-up demand for dashboards that you're suddenly going to satisfy now that they're 1,000 times cheaper. It makes no sense.
But even if you can, I would ask, like, is it worth the cost? Because if it's not generating the value of refreshing it more often, then what is the point, right?
Exactly. So if the question is, what does a business analyst need, or what does that dashboard user need, they have it. That's a really well-solved problem. And we're in the territory there where we were 10 years ago building monoliths, where there were still choices. I had to pick my language. I had to pick which relational database I wanted to use. I had to pick my web framework. I felt like I was defining myself with all these choices, but really filling in a form. Lots of different ways to do a dashboard these days, but really we know what those choices are, and they all work. And it's good that it's a solved problem. Innovation continues. I'm not. This is all bread and butter stuff that's really important. But the case for real time does not consist in dashboards. Like, if that's all you do, then you just don't need to go that fast. We're kind of at the speed we need to go for those.
So yeah, so if I may say so too, it almost seems like latency really depends on your particular kind of use case. And when Tim kind of mentioned too about places, actually some shops don't even use any frameworks and they develop their own. And because I actually work at the Chicago Mercantile Exchange before and the Board Options Exchange, they actually, or at the time, they did not actually use any framework. When I said, oh, what do you use? We write our own in C, and it's much faster than if I use another library, because I just don't want any other layers in there. I just want to write right there and go into the metal, and it does the work for me right
Just
there.
like the trading stuff.
The trading, yeah. They actually do their own too, and they don't want to use any other libraries at all. So I think it all depends. But to me though, like as I'm thinking more and more, we tend to kind of talk more about serving the business, but how about, in my mind I'm thinking, the world has so many problems. Can we solve some of these social problems with streaming? I think that might be actually an interesting thing to think of. Maybe trafficking, right? If we can kind of find out, how can we track, somebody who's I don't know, pedophile or something, things like that, right? If we can find ways, I think that would actually be even a better thing for us to do for humanity to solve the humanity problems. Yeah. So anyway, just a thought that I have too. So.
I think that gets to an interesting point. It's still too hard for people who just want to solve a problem but don't have the technical background. So what I hope we get to is templates, recipes, queries to ChatGPT, I don't know, but things that actually help us set up, not only just like balance that latency and throughput, knobs and cost knobs, but also all the error handling that's required. What are the semantics that should be invoked in failure? These are all really the hard problems that ultimately prove the most difficult. I'd like to see them solved in a standardized way in some sense.
No, you asked, I want to see if it's your next question. No, there's
It's just a comment.
do you have another, okay, do you have more questions?
Yes, I do.
I'm going to let you ask them.
No,
And
you can.
if it doesn't come up, I'll
Well,
I'll get
I
there.
was just, I wanted to add a comment to, I did a little research preparing for a talk about the latency, how important or not important it is. And unfortunately, people are very impatient. And even a second of difference in many cases would make a huge difference in conversions. So many businesses would say that, yeah, we still need that. Having said that,
Can I just, because that's what I wanted to talk, because you just moved who the consumer of the computation was. Because I was saying real time doesn't matter, and I was hoping somebody's going to ask me, well, then why do you talk about it, Tim? But nobody did. So, but for the dashboard consumer, it doesn't freaking matter. It's not actually valuable to spend extra money on that. Oli, you were just talking about a user of an application, a person on a smartphone or a web browser, and now we're in, the game is different.
yeah, because you're doing real-time analytics.
Yes, and I am notoriously impatient when it comes to stuff like that. It's not a good thing. I'm not bragging about that. I should grow in that area. And I'm also, we're all very synchronous in our use of the software that we interact with. Like you touch something and you wait for it to change, and you're not going to wait for long. And so I think real time matters when you begin to interact with humans who now have this instant expectation. Going back to when smartphones entered the world, we just expect to interact with responsive software on devices that are always connected. We can get answers all the time, and more of our life is lived through those devices.
I want
so that
my
matters.
TikTok recommendations now, please.
Yes, yeah. I want to know how long that hamburger is going to take to get to me. It's funny. I'm kind of hungry right now. So anyway.
Okay, so we talked a little bit about different problems, and at some point this thought struck me, and now I forgot why I thought that, but actually I think there is a little correlation, maybe not little, between how established your company is and how big is your legacy code base and how fast you're gonna pick up on the streaming as a technology. Do you agree as panelists, and what challenges do you see there? Is that mindset or actual technology learning curve or something?
Wait, can I unpack that question? Is the question, if you're a established company with a legacy code base, is it that you will not adopt streaming technologies? Is that, or did I misunderstand the question?
Well, let's put it this way, it's okay.
I don't know. If that is the question,
No,
I think it's very nuanced.
My question was that I think that it is more challenging for big legacy systems and established businesses to do so than like something that appeared just a few years ago, for example, and I want to see what ways to improve panelists see you included.
But I think in the way that the question is framed is that the incentives are not aligned the same way for both those companies. When you're an incumbent, your incentives are aligned to de-risk so that your stock price doesn't go down or you don't churn the most recent customer. And if you're a challenger company or not an incumbent, you're trying to leverage whatever capabilities you can, i.e. technology or i.e. real time, to have an advantage over that incumbent. I mean, I don't know, taxi cab companies versus Uber or whatever. So I think that maybe it could boil down to incentives instead of just the code base. I don't know. That would be my answer.
Well, I guess we do have some tools at our disposal. Even legacy companies with a lot of spaghetti code often figure out ways to slice it and and introduce abstractions. So they might spin up a team of the young hotshots to do the streaming stuff that they have to survive, like for customer engagement or customer happiness. But then they'll often figure out ways to shove that data into the mainframe or whatever database and legacy batch system they have. So I think a lot of companies will figure out how to do it, and they'll leverage some of the things that we talked about and know how to do, which is create abstraction boundaries.
So I think at a legacy company, right, which I've worked in finance, and there's plenty of legacy things sprinkled all around in a finance company. It's always hard to adapt new technologies, right? That's, I think, regardless of if it's a finance company or not, there's always some risk there, right? That this thing will fail, or it would not do as well, or incorrect results compared to whatever you have, right? There's always a risk of going to do the new thing. But I think a lot of time what people realize is I think it's two important things. One is maintaining the existing system is just too costly. The people that know this thing has long left, no one knows exactly what the code base is, what things do, and it's just running and no one really knows how to maintain it, right? If something goes down, if something fails, well, tough luck, we're kind of all screwed here, right? So that's one thing, is maintenance, and basically maintenance in the future. I think that's a big factor. I think leadership and a lot of companies take into account is, well, going in the future, we have this legacy thing going on. How feasible is it for us to maintain it, right? Number two is once they kind of, I think, see the potential benefits in adopting some of the new frameworks, right? I think one of them could be maintenance, but there could be other things that these incentives, right, just like you said, like will outweigh the cost of these risks, right? That looking into the future, this is the future direction everyone is going, and we should definitely invest in it and not be like left behind here, right? That the incentives, I can basically make decisions faster or do whatever, and I can get, these very quantifiable benefits, right? Once like customers realize that, and I think education is definitely a piece here. Like once users realize that, it's a lot easier decision to like say, okay, now let's like move over to this new technology.
100%. When I was at Confluent, sales and marketing called this application modernization, which meant there's a monolith and we're going to rebuild it as event-driven microservices, basically, is just have their language for that. So yes, people do that. Other side of the coin is, Mary and I never overlapped at DataStax, but I was there a few years before. The guy who was the CEO at the time, Billy Bosworth, was a young developer during the dawning of the relational database and client-server era in the late 80s and early 90s. I was there, Gandalf. I was there 3,000 years ago. At least he was. I was doing different things. But he talked about kind of the wild-eyed fanatics advocating for that new way of building systems, and they definitely were. I was, in the late 80s, I was a nerdy teenager reading Byte magazine and reading about this client-server thing like it was this massive social transformation, the kind of breathless tones that people wrote about it with. I didn't understand at the time. But those advocates were pushing for this new way of building things, and they didn't just set fire to the mainframes. It wasn't a revolution where you go to the barricades and overthrow the whatever. The mainframe's there. It's fine. It's probably still running the code it was in 1987. When all that debate was happening. Sometimes you build a new thing with the new thing. So yes, 100%, you refactor legacy systems, application modernization is a thing, and a lower risk path for adopting a new technology is, here's this new functionality, this new system, new business that we as an incumbent player are entering, and so let's do that with streaming and real-time analytics and blah, blah, blah. So two different ways of making it happen, and if you're an incumbent player, they don't always just cocoon and die. They build things.
Small R&D projects that never see the light of day. No,
Yeah, right.
Yeah, I was just thinking about the entire architecture patterns for solving problems like Lambda and how to bring that. Okay, so I want to move a little bit into the future, and I want you to share some new, exciting, promising, or nerdy streaming technology that you're following and why you're following.
I'll go first here. So we talked about cost trade-offs. We talked about latency, and we've talked about new technologies, and we've spoken about incumbents and et cetera. And some of us here have worked on Confluent and Kafka, and so a new startup and a new way to think about streaming that I think is really interesting is from WarpStream, and they use object storage, and you have to pay a penalty for latency. But I think what we've all spoken about a little bit here is there's this trade-off between ease of use and what people actually expect, and who's actually expecting things, and do we all need the latency of the bank, et cetera. And so you pay this penalty of latency, but you can have a much lower cost and a much more simple architecture. You're not working just with disks. You have a very decoupled architecture. So WarpStream is my plug outside of ByteWax, which is another great technology y'all should check out. But
So actually, I think for me, one of the interesting things right now is we train these generative AI models in a batch way, and we can't train them often because it's so expensive. So you were talking today, Zander, about, and in fact there were several talks about like the retrieval augmented generation pattern where you keep like the recent data in some sort of database that you can look up and it's associated with your query. I'm going to be very interested to see how that evolves because it's very much a kind of a hacky solution now. It's kind of slamming together streaming in a sense. You know, what's the latest Twitter feed or whatever versus this legacy model that's growing older by the day. And I think figuring out that balance and trying to keep models up to date and not have to use RAG as much, I think will be an interesting trend.
Well, I was going to say, you mentioned about pre-training. I think that would be really breakthrough is if we can actually do the pre-training, right, of LLMs, if we can do it like cheaper and faster. But I don't know how, right? Because right now it's huge amounts of data and it just has to go through that kind of painful process of pre-train and it takes so long, takes so many GPUs. Still, it would take days or weeks. And so I think, you know, and I was trying to ask that question, but nobody talks about it too. I think it's because the cost is just super, you know, monstrous cost to do that. But I kind of have often thought if there's a good way of doing pre-training really fast, like you said, it's a batch processing too, and it just, you just have to go through that. But it's, I don't know. Right now, I can't think of what way. I don't know if anybody has been thinking about it. Can it be done processor-wise, something to make it faster? Can it still be done faster? Or maybe some of you have kind of thought about it?
So I think one of the benefits of stream processing, right, over like traditional batch processing is that stream processing typically it comes with some sort of management of state, right? That you're able to incrementalize your execution, right? You're able to process one part of the data at a time, and you're going to be able to basically memorize kind of the progress you've made and basically continue, right? And what that really gives you is allows you to only process the difference, right? The changes, right? So that's I'm not an LLM expert, but at least in terms of like what I think is a very interesting thing that I believe in is materialized views and using stream processing to power materialized views. It's not necessarily a new concept per se, but I think it's, you know, a very powerful concept that can allow users to that allows users to use stream processing in a more user-friendly fashion. People don't have to go and think about, oh, you know, event time, watermarks, late data. Doesn't really matter. I have a materialized view. I want to basically refresh it. This is my refresh interval. I want to commit this amount of dollars. Go figure it out, right? And basically using stream processing to incrementalize your queries so that you can also reduce the cost for your materialized views. And that's something at Databricks we're working on as well, which is, I think, very powerful and very like easy for users to reason about because like materialized views, that's something like people understand, right? Not necessarily like if you know anything about databases, SQL, like materialized views, I get that, right? I get that. I can query my materialized view, and I can get the result, right? And I can use stream processing to incrementalize my query to lower the cost. So I think in terms of like what I see as you know, exciting things is not necessarily something that's broadly like, oh, the hot thing, but like one is, you know, using basically familiar querying concepts and somehow applying a streaming, you know, spin to it, and also just making it simple, right? Making it user-friendly. A lot of running streaming is one, it's I don't understand the concepts, I don't know how to run it, you know, in production, right? So at the end of the day, if you can't just say, oh, I have a materialized view, I want to update it in real time, and all of the auto-scaling, running, you know, cost equation is all solved for you, that becomes very compelling to the end user to like say, oh, it's super easy for me to adopt this kind of thing.
Did you say, I have this is my budget, I want you to like solve this materialized query using my budget? Is that what you said?
Yeah, I want to be able to say, what is the freshness of my materialized view, right?
That's super interesting, actually. It would be really interesting to see the data, like how much are people willing to spend for various different use cases or various different materialized views to get what they want. Is it like fundamentally half of the data problem is like, hey, I want this data in this shape to be correct and be in this place at that time. And like, how much are you willing to pay to get it there? So it'd be really interesting to see the data. I don't know if is that the thing that you're doing at Databricks? It'll be like.
Yeah, so it's related. There's another product called Delta Live Tables that basically allows you to do that as well. So, I mean, at the end of the day, look, like when you talk to any of our customers at like at a senior leadership level, the bottom line is how much is this going to cost us? Like none of the other things are details for engineers to figure out, but like is what is the dollar amount here? Like.
Any exciting technology for you, Tim?
Okay. It's a tough one. I'm not very good at the future. I mean, there's the stuff I work with. I'm excited about that, but what's the far out? I was going to say AI as a joke, but then Dean and Mary actually had thoughtful things to say about AI, so that didn't work out. Yeah, to some degree, the stuff I work with Pinot, that is a very forward-looking thing because the practice of user-facing analytics is not yet exactly ubiquitous, and that's mostly what I focus on.
Okay, so I want to ask my last question for today, and then we're gonna move to the audience if they have questions. So the main theme of this conference is the code and data in the age of AI. And we'll look at it holistically. We want to learn how to build AI systems, how to leverage AI system on your, on everyday basis. If you can use Copilot or something at your work, please tell us. And here at the streaming panel, I wanted to ask, in your opinion, does streaming matter in the age of AI? And if so, where does it fit and how it helps?
I'll go first, I guess. We can go in the order, or near the order we've been going in. So earlier I spoke a little bit about why I worked on Bytewax and online machine learning, and I use this term like operational transforms with respect to real-time data processing to avoid talking about analytical transformations, which would be more suitable for Pinot or something like that. And the reason I talk about those is in the age of AI, we can do, so operational transformations are a part of automation. So when can you embed logic in the application so it can have machines talking to each other? In the age of AI, you could imagine that increases potentially. And I think that stream processing is a really important part of that because you have to understand the context of what is happening in many different streams of data, essentially, so that you can make a appropriate decision in real time. And so all of this to extrapolate that more and more automation because of AI will lead to more and more, will necessitate more and more stream processing and streaming platforms so that we can understand what's happening in real time and have things react to it appropriately. Like, we're humans right now, we're taking in so many inputs and we're making decisions in real time. And so if we were to take that and make it into a machine making those decisions, we have tons of ability to take in input, and they have to be able to take in similar types of inputs in streams and perform some understanding of what's going on so they can react to it. So I would say yes. TLDR, yes.
Are we going in order?
We can.
Yeah, I don't want to disappoint anybody, but my answer is also yes. So I'm going to attempt to summarize what's going on in AI, and I could be absolutely wrong, so disagree with me, audience, whatever. But like in the last 10 or 15 years, we've had this steady march to being really good at classifiers. Deep neural networks have just made really good classifiers. And then in the last year, all of a sudden, generative AI is a thing. That's, the kind of ChatGPT in the public discourse is about a year old now. And that's a game changer for all of us. I mean, I don't, in my role, write code all the time, but when I do, I'm kind of in ChatGPT asking questions, it's great. And I'm learning how to use Midjourney and just have fun with that. And these are real things that I think are much more limited than we might like to talk about all the time, but impactful tools. But the current obsession is driven by generative AI, and that doesn't mean anything for how my services talk to each other, or for how I respond to events in real time and get results to users of an application. That's plumbing. We're still plumbers, and that work continues unabated. Maybe you've got Copilot, and that pain in the butt API, you don't have to go look for an example that's not even there in the docs. It'll just give you something, or ChatGPT will. Game changer, okay, not to be discounted, but the actual conduct of our jobs, if you're, a typical, say, enterprise software developer, is the same. Which means streaming still matters for all the reasons that streaming mattered 5 minutes before everybody knew what ChatGPT was.
So I think this is an interesting question. From my perspective, machine learning, AI, right? Sure, there's newer innovations that can help, stream processing and vice versa, but the fate of those two has always been intertwined from the beginning. Like, especially when I look at back in the day when I worked at, Yahoo, when it was still its own company, right? Those days, right? When all the founders were still there, right? So it's always been big data. One of the big drivers of the development of big data platforms was machine learning. Was because there was so much data that we want to do some sort of machine learning on there. We developed these distributed systems to process that, right? And a subset of that was stream processing or distributed stream processing. So when I look at the use cases, especially back in the day, like back in the day we were using Apache Storm, right? A lot of the use cases was online machine learning, and if anyone knows, like actually Yahoo was an early kind of pioneer in online machine learning. There was an open source project called Apache Samoa back in the day. It was a whole library built on top of Storm and later ported to other streaming platforms to do online machine learning. So it was always, the fate of these platforms was always intertwined to some degree. It's been that for, I think, a while. So I think it's obviously still gonna continue. The reality is, for any of these machine learning algorithms to work, it requires a lot of data and the infrastructure, right, to process that data. So those things will always be hand in hand.
Yeah, so I look at it, it's true, because we are actually living in a world we depend on the data. So the data is really the thing. And then we have different ways of getting the data, travel here and there and going, kind of morphing it, whatever. So I think streaming definitely will be there. And I also look at it, like Tim said, it's like plumbing. We're just plumbers. How do we get it moved from one place to the point A to point B? That is always what we're trying to solve. If you kind of think of boiling down to some bare bone thing, we're trying to move data from one point to the other. We're constantly doing that. And so streaming is the technique. So I think it will always be there. It will, and it's definitely true. It has kind of before, when we were doing things synchronous, and now streaming enables us to do things more in an asynchronous fashion. So I think it will continue to stay. It just won't go away. And maybe we have new ways of handling it, but we're still dealing with the data. Like you said, Jeremy, right? Talk about the data. We're still dealing with it, and streaming is there. RESTful thing is there, but I think the key is to try to figure out what we're trying to solve and then apply the right techniques, use the right tools for the right job. I think that's what we want to try to do, understand our problem clearly and then apply the right jobs, right techniques and tools to it is what I'm thinking, so.
So I think we've all seen these futuristic police shows where some guy starts talking to an interface and he drills into this data, cameras looking over a whole city, and suddenly he's narrowed it down, and he's actually interacting with this thing that has this superhuman knowledge of what's going on, and then maybe runs a query by talking to the system, or tell me a little bit more about that guy that you just identified in the camera. So I think it's absolutely correct that streaming is going to have a massive impact here for all the reasons that we talked about in talks today about the RAG pattern. Everybody wants the latest data. It's a pain that OpenAI is stuck in 2021 or whatever. So I think it's going to drive a lot of evolution about how we hybridize these kind of very different technologies, because people will want to be able to do that stuff. We just invented like the best query language we've ever had. We can actually, you know, somebody who doesn't know anything about SQL can actually query a database now. And they might get the right answer depending on how much it hallucinates. But, you know, it shows what's possible, I think.
All right, thank you. That was a really interesting discussion, and I want to continue with the questions from the audience.
So during this entire discussion, the thing that kept coming to my mind is whether or not, you know, there are very small number of use cases for streaming. And the reason for this is because for me, it feels like overkill most of the time, unless you're doing real time, lots of data, like people like Twitter, because otherwise it's just event-driven architectures. You got a bunch of events. Worst case scenario is that you do quantized events of time, and you deal with events as they come. So serverless type of architecture. Trying to do streaming is mixing, you know, is overcomplicated the issue, overcomplicating the issue. What do you think of that? Or do you see event-driven architecture and streaming style architectures as being completely different?
Well, I definitely think there's the, like, event-driven architectures is here to stay, and that's what we want. You don't want to wait, you don't want one microservice to wait 5 minutes for a reply. But just on the case of data, if you think about it, even batch processing is actually like a finite stream, because whether it's Spark reading a file, you know, one row at a time, or even it's pretty much anything we use. So there has been a lot of discussion about really they're kind of two sides of the same coin in a sense. And whether you find a streaming architecture for even your batch analytics is the right model kind of depends on your sophistication and the tools you have. Or conversely, you run a batch job every minute, and that's sort of streaming, but you've got your latency budget met. So I really do think you have to decide, to the points that have been made, what is my latency budget, what is my cost budget, and what's the easiest way to get there, I think, whether you call it streaming or not.
And complexity of the software. So it might be, we talked about monoliths earlier, it might be that that's the right architecture, and that all of this event-driven stuff is actually overkill. So there's a scale, a very legitimate scale at which build a dang monolith. And if you don't need these things, don't do them. I mean, if, like you said, a function call is literally hardware resources in the processor to make that work well. You know, instead of going over the network. Why would you go over the network if you didn't really have to? So if you could build something in a monolith, it runs, it scales, you can deploy it, you can test it, you can fit it into your head. Yes, every day. There are times you can't, but I would say that that's the right thing to do.
I would say, like, really there's no difference. I mean, I think the distinction here is what you're saying is, are you using a stream engine, right? Are you using one of like the platforms to do stream processing versus I just wrote a jar and it processes event by event, right? In reality, those are just implementation details. Like, this is just streaming, right? You're processing live data, you know, as it comes in. So it really, to me, there's no, you know, there's no kind of distinction there. It's just a matter of what you're using underneath. Yeah, it depends on your use case, right? If you're just say moving data from point A to point B, what is the point, right? Like, if that's the streaming use case, or you're doing some sort of, you know, trivial operation, right? Arguably, sure, if that's all you're doing, right? Maybe it's just worthwhile to just develop your own custom application to read data in and pipe data out, right? So it really depends on kind of what the application is, what potential applications you're going to develop in the future, right? If this is just a standalone use case, or do you think, oh, in the future I'll build 100 of these use cases, and I don't want to write a custom thing for every single time. I want to have one single framework I can declare all of these transformations on and just run it, right? Like, these are kind of things you have to think about. But at the end of the day, I think that's just, streaming, whether you develop your own thing or you use another, platform.
And you usually know when your bacon is being saved by a tool. And if your bacon is not being saved by it, then it is not.
Get new bacon.
What's that?
Get new bacon.
Get new, well, or that you don't need that tool. If it doesn't appear as a useful thing, probably isn't. And then to people that it does appear to be useful, it is. Just depends what you're doing.
Yeah, right here. So a few of you guys talked about the trade-off between cost and latency. The authors of Apache Beam said the trade-off is actually 3 dimensions. It's cost, latency, and correctness, because in a world where events may arrive late or out of order or never arrive, right? We don't know whether we're materializing correct results. And so, there's streaming as kind of a execution paradigm, right? But there's also at the application level, right? If we're dealing with streams of events in the real world, that's streaming, whether we process it in batch or using a stream engine. So just curious to hear a perspective on the panel on that.
Yeah, we talk about the question before was why do I have to take on all this complexity? Or should I even do it? It's too complex. And I love how we force people to ask the question of how correct do you need to be? Oh, sure, you can do stream processing, but how correct do you really need to be? How long do you want to wait until you're correct? It's really fundamentally kind of weird thing to think about. And that we haven't crossed the chasm, so to speak, I don't think, with a lot of streaming technologies, because we make people have to ask and answer a lot of those questions, which you just fundamentally don't want to have to deal with. You're like, why would I try and think about how correct I need to be when I can wait 5 minutes and process the batch or whatever. So, and use batch tools that are easier. And so I think coming back to the very first question, and maybe I'm not even answering your question, I'm just ranting now. We haven't really crossed the chasm because it's still so freaking complex and hard, because there are hard problems we're trying to deal with, like was mentioned in this panel. And we expose those to the users everywhere. They're like, oh, you want it to be eventually consistent at what, or, oh, sorry, your whole entire system isn't idempotent, so now you're gonna have to mess around with your guarantees. And it's there are so many hard questions you still have to answer that you shouldn't have to answer in your day-to-day life, so why the hell should you answer them? So, I mean, I don't know if that answers your question, but I think the whole thing I'm trying to say is just too damn hard still. Why do you have to have that third dimension you gotta answer the question to? It should just be cost and complexity. Someone else deal with the rest. Hey, I paid for you to solve this problem. I didn't pay for you to tell me, look, if you really need your answer to be right, you gotta wait for 1.5 minutes today.
So, and I was thinking exactly about the opposite. If you wait for 1 minute, then your answer might not be the correct one anymore. So it's stale. Yeah, and I don't know, the stock went down and now you're about to lose your money because you clicked too late. So, yeah, correctness is hard.
I have a question. Going by the crossing the chasm thing, if you want to reach wider audience, what are the, I want to hear more about the user experience with respect to streaming and the future of user experience. So today is a little bit more developer focused experience, right? So if we want to really simplify this for high level thinkers, who are thinking about use cases rather than the technology in itself, and want to leverage streaming. So what is the progress being made towards the user experience? And how do we think we should evolve so that people don't have to think there is streaming underneath, right? And yet be able to get real-time information from the systems. So yeah, I want to hear more about the advancements in the user experience.
Yeah, so I think I talked a little bit about this is using basically existing concepts, right? People maybe know from SQL that are just powered by streaming, right? One of the things I think that I mentioned is materialized views, right? People understand that. Traditionally, materialized views in a database, you recompute across a whole data set, right? That once data comes in, you recompute basically the new data with all the old data, and that's very costly traditionally, right? But with stream processing, you can incrementalize that compute to some extent, right? Depending on the query. So those things, like I do think, does allow users that maybe not really familiar with all of these, streaming concepts to use streaming technology indirectly in some way, right? Of course, there's also, things that, we're also, exploring at Databricks, like, can we use like LLMs to go from natural language to actually, some sort of query, right, by themselves. That could also obviously help, right? So I do think it is important, but those are kind of some of the things I'm looking at, and as well as not necessarily, I think, the defining what you want to query, but also the operational side of things. Is traditionally that's always been very hard to run a streaming query, in a production setting. But if you were, given basically some sort of mechanism to fire and forget, that it will basically scale to whatever load, and it would be within kind of your SLAs, that would make it very usable to the end user, that they don't have to worry about the nitty-gritty details of operations.
Impacting user experiences, like precisely the thing that I'm trying to help developers who are building these systems do more easily. So examples, LinkedIn, that's where Pinot was born. You can't load a LinkedIn page without lots of things being impacted by decisions that Pinot is making. Meal delivery globally, for whatever reason, it's this vertical that Pinot's I don't know why, but like all of the meal delivery companies on the planet, getting food to you quickly for too much money, with you not having to go anywhere. That's all real-time analytics powered stuff. Finance in ways that they don't like talking about. Stripe, which counts as finance, but sort of like mom and pop finance, they've got actual, dashboards. I said dashboards didn't matter. They have dashboards where it does matter, that they do need to be real time. Various retailers who also don't always uniformly like being talked about by name, with behavior on their website being directly impacted by user-facing analytics. So ever-growing list of use cases. And the whole point of the stuff I work on is to provide experiences to people who are using computer programs and make those experiences richer, more engaging, stickier, more valuable, however the business is measuring that. But we're generally, utility maximizing actors, and so those features actually have to do things that we like in order for us to use them, and that's the goal.
All right, everyone. First, I want to thank our panelists, and I want you to give them a round of applause, please. And thank you, everyone, for today. And we have a happy hour in that room. Thanks to our sponsors. This event is happening today and tomorrow, so give them some love and attention. Thank you.